So this project is, or it's actually two SIOS instruments, 42 and 43. It's all about using long-term time series of satellite data and try to establish time series of snow parameters over Svalbard. So I've done this together with quite a few of my colleagues at NORCE. I should also mention that this part of SIOS is funded by a Norwegian Space Agency. So the first instrument had a number of snow time series that we should deliver as milestones, and we started off with preparing a MODIS snow cover fraction dataset from 2000 to 2018. And this dataset has been further updated for the last 2 years. So it should be updated to 2021. We also have delivered data on synthetic aperture radar, which we can use to derive wet snow cover on Svalbard. And we also have several other data sets like the AVHRR snow cover fraction data set that it's a little bit delayed, but we're currently working on it. The QuickScat data set has not been worked on during the project, but we have, I will come back to that later, but we have all the other milestones have been completed according to plan. So to go through the details, this MODIS snow cover dataset, we produced a time series. In these figures, it's all the way to 2019, where we can see the total snow cover fraction as a function of day of the year, and we're also able to derive the first snow-free day and the last snow-free day, and also we could derive the trends to see how much earlier or later the first and the last snow-free day occurred during this period. So over 20 years, it's most part of the coastal areas are more than 3 days earlier than by the end of the period than by the beginning of the period. And in addition, we have also validated these products against the MET stations available. It was not so many covering the entire period from 2000 to up to now, but at least we have some quite good results by comparing MET station data to the snow cover fraction. And we also did in a paper, we compared these snow cover trends with the trends in normalized differential vegetation index and also the sea ice concentration. The wet snow or the SAR wet snow dataset has been studied, and we are able to provide almost daily data from 2004 up to now by combining data from the sensors ENVISAT ASAR, RADARSAT-2, and Sentinel-1. From these data, we can infer rain on snow events and also the melting periods, the extent and the length of these melting events. And this work has been submitted to Frontiers of Earth Science just recently. As I said, the QuickScat data, according to the original plan, we were planning to process the sensor QuickScat on board a NASA satellite called SeaWind into snow water equivalent maps over Svalbard based on a retrieval method we have developed for some years. But we had to abandon this idea since the scientist responsible is no longer available. Instead, we suggest to replace these studies with data using Sentinel-2 and ISAT-2 to improve the quality of the snow cover data. The AVHR dataset will be processed into 1 kilometer spatial resolution. This dataset could be useful to supplement the Met Norway AVHR GAC snow dataset published by Killie in 2019, which had 4 kilometer resolution. And we actually have studied this and compared it with the other datasets that we have available. So it could be very interesting to look if we get more or better results with 1 kilometer resolution. And we will provide this as a interpolated daily snow cover fraction series into the SIOS data management system. So the Sentinel-2 snow cover fraction, it's of course only available since Sentinel-2 was launched in 2016, but it has a very high resolution. And as you can see to the right, when you compare the snow cover in Adventdalen on a specific date with Sentinel-2 and with MODIS, it's quite much more detailed. We used this 4-year data set and compared it with MODIS, and we also compared it, or we did intercomparisons in assess report against the AVHR and also snow models from Se Norge by NBE and EBFN from University of Uppsala, and found very interesting differences and similarities in these data sets. So this is worthwhile to study further on to look how we can provide as best as possible long-term time series of snow cover over Svalbard. Since the start of this project, we have collected annual TerraSAR-X data over Svalbard at the snow maximum, which occurs usually around 1st of April to May. It has we have to assure that we get data under dry snow conditions. So the dates have varied a little bit from year to year, but at least we have 4 years now and soon 5 years of these data sets. And the idea is that we can that this X-band SAR data is sensitive to snow mass or snow water equivalent. So, and it's much more sensitive than normal SAR, which we have, of course, a lot of with Sentinel-1. So by using a snow-free reference scene that we acquired in October 2018, we will try to find the correlations between the snow depth and snow water equivalent that we have measured in the field campaigns and compare them with the satellite data. So these plots shows that at least 2019 seemed to be a much more snow-rich winter than the other winters. Okay, the next work that we have started off quite recently is to use data from ISAT-2. ISAT is a LiDAR, or a laser altimeter, which provides these very thin transects, for instance, across Adventdalen that were acquired in the year 2020-21. And by using this Atlas 6 product, we can and do some processing, we can compare the snow-free and the snow-cover data to get the snow depth. So this figure shows how the snow depth varies across the Adventdalen for the last winter, yes. And these data, we will compare them against the in-situ data we have, both in Adventdalen and surrounding regions of Longyearbyen where we collect data. Okay. Another activity that we have been doing is to detect snow avalanches on Svalbard based on the same algorithm as we used in Satsskred, the Norwegian hydrological directorate in Norway, which is responsible for snow warning. They have implemented a method that we have derived at NORCE, where we detect snow avalanches using Sentinel-1 based on change detection techniques. And we have run this algorithm on Svalbard for 4 full seasons. And we find, as you can see on the image to the right, a heat map of the relative frequency of avalanches. And we have also tried to compare these to meteorological factors to find correlations. And the idea is in the long run to use in combination the meteorology and the avalanche heat map to improve the avalanche warning on Svalbard. So a paper on this is in progress and will be finalized this year. So the next instrument is on validation, and we have carried out 3 field campaigns until now. Of course, the campaign in 2020 had to be cancelled due to COVID. And we're just now planning the last field campaign. We have published papers on both the MODIS and the SAR dataset, and actually also on the combined optical and SAR dataset. It's in the same paper. The QuickScat dataset will be replaced with the Sentinel-2 and AVHR, and we're working on the TerraSAR-X dataset right now. As I said, we have carried out field campaigns so far for 3 years, and we have used the same sites in and around the Adventdalen Longyearbyen area. So what we do is to dig snow pits and do extended snow depth transects. And the most important part is, of course, the drone-borne ground-penetrating radar measurements that are being carried out. And the dataset will be ingested in the SIOS database. Here's an example of a Dpr measurement. Of course, remember that the drone is flying about 7 to 10 meters above the ground, and we can see that we can measure very detailed information, obtain very detailed information about the snow cover, the air snow surface, and the internal layers in the snow, and of course also the ground. So we have compared the GPR measurements with the in situ probing measurements, and it looks very good. We have a very high correlation between the radar-derived snow depth and the in situ snow depth. And we can also, by doing gridded measurements, we can make these interpolated snow depth surfaces. Okay, to publications, we have, as I mentioned, a few, but this is a complete publication list. And we also have a few both submitted and planned, and even a popular scientific contribution in a drone magazine. Thank you.